Yeah. So we have Michel Fodje from Canada Light Source, please. Yeah.
Okay, good afternoon, and my pleasure to be able to join NoBox this year. So I want to take the next 15 minutes or less to talk about what we're doing at the Canadian Light Source MX facility to integrate our data acquisition and data processing systems. So the macromolecular crystallography facility at the CLS makes use of 3 software packages, MX Live, MX DC, and also a data analysis server. And we have 3 reusable components that I'm going to be talking to you about this afternoon. So CMCF is the MX facility, and it has two beam lines that are complementary. We do mostly MX. Our user community is 60% academic, 40% industrial, and more than 90% of our usage is remote. So here's just an outline of the software architecture. So you have MX Live, which is our LIMS system. MX DC is a single user interface, graphical user interface that is used for data acquisition. And then we have a data analysis server. And our users interact just with MX Live and MX DC. And all of this is supported through a storage system, an HPC cluster, and linked through a 40 gigabit network. So MX Live has multiple features, but I just want to highlight here just a few. So you have visualization of the data as it comes out of the experiment. So we have experiment monitoring of all the various types of data sets. You have images, you have scans and XRF scans. We have visualization of data analysis reports within the interface. And MX Live also has lots of statistics that are generated from the metadata that we collect within MX Live. So MX Live is similar to iSpy-B for those of you who are within the MX community. And the software was developed back in 2010. So it's quite old and has been updated a few times. MXDC, on the other hand, is, like I mentioned, that's the single user interface. So our users interact just with MXDC when acquiring data. And it's integrated. It has activity pages for the different steps required for data acquisition. There is automation built in. For example, we have AI-assisted alignment of samples for identifying crystals and loops. We have data visualization. You can also look at the same scans that I showed for MX Live. And there is automated analysis of XRF scans built in. And also data analysis. So every time a data set is acquired, a request is made to analyze the data. And the request is sent to the data analysis server. And when the results are ready, they're sent back to MXDC. And the user can visualize the graphical report right within the software. And so you see there's scoring. On the left hand there's scoring of the various data sets, so the user can see what the quality of the data set is and to be able to make better decisions about how to proceed with the next samples. So I'll switch now to talk about the 3 pieces of software that we've developed to help us with the data analysis system. And that is, we have the data analysis server that is used for orchestration. It's based on a framework called Swift RPC. And then we have a parsing framework called Parsefire, which is used for wrapping third-party packages. And then we have MX Live reports, which generates all the reports I showed you and the statistics. So Swift RPC is a 0MQ-based, simple remote procedure call system. So it's really easy to write servers and clients. And I'm going to be showing you some examples. So our data analysis server is written using the SZRPC, Swift RPC, that's just the name of the Python module. And you can write a server, you can write workers, and the workers support, you can have multiple workers per server, and you can have load balancing of the workers, and you can have multiple replies per request, and also you can integrate it with GTK and Qt signals if you're developing graphical user interfaces. So here's an example of a server written using Swift RPC. You just import the service, and then you define a subclass with methods prefixed with the remote keyword, and that's all you need to define a Swift RPC server. And you can do whatever you want within the methods. You return the final result at the end for a single reply, or you just tag a reply to the request object, like shown in the last example there, for multiple replies. Let's say you want to indicate progress of the process. And then once you've defined that, you can create a server like that, provide two ports, one for the front end and one for the back end. The back end is used for the workers to connect to, and the front end is for the clients. So here's an example of how you would define a worker to connect to the server. And you can run as many workers as you need on multiple different computers, and the work will be load balanced between the workers. And here's an example of a client. So a client is event-driven, and it automatically discovers the remote methods that have been defined. Or if you want to restrict available remote methods, then you can specify them manually. So you connect signals on the client to various activities, like when the work is done, or when there's an update for multiple replies, or an error. And you attach callbacks to those, and those will be executed when the data arrives. So we use the data analysis server to wrap multiple packages. We have one called AutoProcess that we developed. This is an automated data analysis pipeline for data reduction, for MX data reduction. And it's an expert system. It's based on XDS from Max Planck. And it also uses Phoenix and the CCP4, some CCP4 tools. And it converts our diffraction images to MTZ files automatically. And it generates graphical analysis reports that are presented within MXDC that I showed. We also use it to wrap Dozer, which is a software package for analysis of raster data sets. So that's the example showing what we use the Dozer for. And the rastering analysis works directly on Eiger streams. So the Eiger stream data goes directly to our workers and processes the results and sends them back using the multiple reply option. So Parsefire is the tool we use to do data mining from log files. So for example, we have lots of third-party packages that we want to wrap, and some of those packages produce unstructured data, like the example shown there, and you may want to extract various fields of various parameters from those data log files, and that's a common problem that occurs, and most people would just write a custom Python script for a particular file to parse that file. But the Parsefire tool allows us to write a parser specification that specifies the type and the field name, and it uses that to generate a parsing regular expression. And then it parses the text file, extracts the data from it, and does the type conversion. So you just give it a parser specification, and then you get a dictionary out of the Parsefire. So that's an example shown there with the types. And there are lots of different types that are supported, and you get a dictionary output. You could even create a YAML file with the specification, And if you have files that are recurring and you want to be able to extract. And those are just some of the data types that are supported, or the field types supported in Pacifier. And this allows us to be able to wrap lots of different packages. So the last tool I want to talk about is the reporting framework that we've developed. It's based on CSS, JavaScript, and HTML. And it's for generating those nice reports that I showed you, and all the tables and plots. So for example, the tables and plots that you see on the right hand were all generated using this tool. So you simply provide a dictionary, a Python dictionary, or a JSON file, and it uses that to generate the report. So here are some examples. This is a data analysis report from AutoProcess that is displayed within MX Live and also within AutoProcess. And the report is generated, as I mentioned, in a Python dictionary. And you specify content blocks. And each content specifies the type of report section on the report you want to generate. It could be a table, or it could be a plot. And those are the various types of plots that are possible. So here, for example, that's a table. And that's the report block up there. And you could do a plot like this with annotations. And you can also do bar charts, histograms, various types of stacked bars, scatter plot, and even timeline plots. So the way you use this is quite easy. The three files, report.html, the JavaScript, and the CSS file, those are written files you don't have to modify. You just have those in the same directory, and you provide your data in a report.json file. And that allows you to be able to display a graphical report for the user. So if you're writing a wrapper for a software and you want to generate a report, all you have to do is generate your JSON dictionary, and it will produce the report to be visualized in an HTML viewer, for example. And all of what I've shown you today was developed by myself and one of my colleagues, Catherine Jansen. And I would like to thank all of my colleagues at the CLS who have contributed in some way to this endeavor. And you can contact me at my email address if you're interested in learning more about any of these tools. And just at the end of my presentation, the slides online, you can find additional slides if you want to see more about some of the capabilities that we have in our software. Thank you.
Okay. Thank you for a nice talk. I have time for one question.
Hello. I didn't catch the name of the package or software that you use for generating HTML report.
So it's part of the MX Live package. Okay. So if you follow the link, this link, it will take you directly to the folder where you can grab those files. You just need those three files, and that's all you need here.
Thank you.
So why RPC over ZMQ? What about RESTful?
Yeah, so we use 0MQ we use 0MQ for network communication, and then we use message pack as the serialization between the client and the server. So was that your question?
Yeah. So that's the RPC will get a message back, right?
Yes.
Okay, thank you. Next talk. So, okay, sorry, I didn't.